Hey everybody, and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy where we are learning networks together. And on this video what I'm going through is VSTP or VLAN Spanning Tree protocol. And this is really another member in the STP or Spanning Tree protocol family. There's STP, there's RSTP, there's MSTP, and then there's VSTP. Now, for those of you who have come or in the Cisco world, VSTP or VLAN Spanning Tree protocol is equivalent to the PVST or PVST plus, i.e. the per VLAN spanning tree or per VLAN spanning tree plus. There's really no differences, minor subtle changes. But really the concept of VSTP is per VLAN, as the name implies, per VLAN Spanning Tree protocol. And what that means in English is that there's a different spanning tree bridge. There's a different spanning tree for every single VLAN. So if you think about it for a layer 2 network in typically an enterprise environment where you've got 10 VLANs, 20 VLANs or even more, then for every single VLAN, as I said, there's going to be a different instance of spanning tree actually running. And that does have some benefits, such as for every single VLAN, you could have a different route bridge for the network. So if you've got 3 switches in your network and 30 VLANs, you could have 10 VLANs assigned to switch 1, another 10 assigned to switch 2, and another 10 assigned to switch 3, just for example. So that allows you to load balance that network through your layer 2 network, because obviously in spanning tree there are going to be links which are discarding. But the downside of VSTP or PVST-PVST plus is that it's process heavy. For every VLAN there's a different spanning tree actually running. There's different BPDUs for every VLAN that's been sent out, and that takes a lot of, or requires a lot of resources, both on the switching part to send, receive, buffer, process all those BPDUs typically every 2 seconds, but also that's a lot of bandwidth that's actually been wasted on the links themselves between those switches. And that's why in the previous video I talked about MSTP. If you don't know what MSTP is, just check out this link, it's all described there. That's why typically you see MSTP being used when there's per VLAN spanning tree, because it just addresses those limitations of VSTP or PVST plus in the Cisco world. So what we're going to go through in this video is, of course, how to configure VLAN Spanning Tree protocol. But first, let's just start off describing the lab, the general setup, and we'll go from there. And here is the lab for this video. As you can see, it's not very complicated. All there really is are 3 switches. There's switch 1, and then there's switch 2, and then down here there's switch 3, of course. And going to each switch there is obviously 2 different links. So from switch 1 going over to switch 2 we're using the GIG 002 interface, and from switch 1 down to switch 3 we're using the GIG 003 interface. And likewise the interfaces have a little bit of a logical number to them. So from switch 2 we're using the GIG 01 to go to switch 1 and GIG 02 to go to switch 3. And obviously the switches have a little bit of a logical order to them. So on switch 2 the GIG 01 is going to switch 1, the GIG 03 is going to switch 3, and likewise, guess what, on switch 3 the GIG 01 is going to switch 1, and the GIG 02 is going back to switch 2. Just easy to remember interfaces. But more importantly, it's not really important in terms of the interfaces. What is important is right here, the actual VLANs. Now this is VSTP, this is per VLAN Spanning Tree protocol, or the standard is just called VLAN Spanning Tree protocol. So what there is in this network and what we're going to do, really on switch 1 and switch 2, switch 3 has already been configured, so I'm only going to show you it twice, is that there's 3 different VLANs. There's VLAN 10, VLAN 11 and VLAN 12. And what you can actually see, what the objective is to achieve that load balancing is we need to have a different route bridge for every single VLAN. Now, if you don't know what a root bridge is, if you don't know what the theory is around spanning tree or RSTP, because VSTP is built, it has all the benefits of RSTP or rapid spanning tree protocol, then please check out this video. The theory is really described there. But really what we want to do is have a root bridge for switch 1. So switch 1 is going to be the root bridge. For 11, the root bridge is going to be switch 2. And for the third VLAN, VLAN 12, the root bridge is going to be switch 3. Now, how are we actually going to achieve that? It's really just done by manipulating, using, configuring those bridge priorities. So within a bridge identifier, you've got the chassis MAC address. That's not the MAC address of the interface, but of the switch itself. And then you've got the priority field, which increments in 4096 values, because that's the upper limit, the upper maximum number you can have for any given VLAN. So from 0 to all that to 4095, so 4096 different values. But to achieve all of these different root bridges here for every single VLAN, if we just look at VLAN 10, and the root bridge for this is going to be switch 1, which is right here, you can actually see the priority, and I've color coded them in green. Not the color, but the priority for VLAN 10 on switch 1 is 4096. But if we look at VLAN 10 on switch 2 and on switch 3, and in fact I'm going to make them the same color, so we've got 4096 here. On switch 2, the priority is 12K, and on switch 3, the priority is 8192 or 8K. That's important because with priority, the lower the value, the more preferred it actually is. So since the VLAN 10 on switch 1 has a value of 4096 versus 12,000 here and 8192 on switch 3, then that is why the switch 1 is the root bridge for VLAN 10. But if we also look at it from VLAN 11, so for VLAN 11, the root bridge is going to be switch 2, which is right here. The priority here is 4096. The priority on switch 1 for VLAN 11 is 8192 or 8K. And likewise, the priority on switch 3 is 12K. So thus, the switch 2 is going to be the root bridge for VLAN 11, and the backup would be switch 1 here because its priority is 8K, and if switch 1 fails and switch 2 has failed at the same time, then guess what? Switch 3 is going to come in with this low priority of 12K, but it would then become the root bridge. And finally, for VLAN 12, we want the root bridge to be switch 3. If you look here, the priority within that bridge identifier, the priority on switch 3 is 4096 or 4K. The priority on switch 1 is 12K, and the priority on switch 2 is 8K. And that's how we're able to get a different root bridge for every single VLAN, because we are using those priority values that are within those BPDUs, those bridge protocol data units, to tell other switches, I am the root bridge for this VLAN. I'm going to have all designated ports, and you need to elect a root port, but also in here you need to assign a discarding port where there'll be no network traffic going back and forth, because that's how we break a loop. And essentially that's the role, that's the job, that's the function of spanning tree protocol, RSTP, MSTP, VSTP, is to create a loop-free topology at layer 2. So this is the lab. As you can see, straightforward, 3 VLANs, different priority values. And as I said, we are going to do this on switch 1 and on switch 2, and then we'll go into the show commands to validate what ports are in what row and have these switches actually elected themselves as that root bridge for that particular VLAN. And here we go. Let's start with the configuration on switch 1, and then we'll go on to switch 2 and pretty much do the same thing. Obviously the priority, the bridge priority values will be different for every VLAN, but that's just a bit of duplication. We're going to do it quick on switch 2, but just to show you again the configuration from switch 1 to switch 2. So hopefully by the time we do it on switch 2, it's a little bit more cemented in there. Okay, so let's go on to not switch 3, but switch 1, and let's go into the command line interface and into configure mode. Now, you would think first of all we need to go into the interfaces. But if I actually just do a show VLANs, you can actually see there's no VLANs currently configured on switch 1. And where we want 3 VLANs, VLAN 10, 11 and 12, obviously we need them configured. So let's just do first set VLANs, spell it right, VLAN 10 with VLAN ID of 10, do the same for 11, and finally 12. That's it, that's the interfaces, sorry, that's the VLANs configured. And now I can go into the interfaces and configure the GIGI002 interface and the GIGI003 interface to go to switch 2 and switch 3 respectively. But if I do a quick show, you can see I've only got my management interface there to connect from my secure CRT for SSH basically. So first let's do the set GIGI002.0 family Ethernet switching, which basically means layer 2. This needs to be interface mode trunk, and I want to trunk some certain VLANs onto this interface. So I'm going to do VLAN members, hit question mark, and you could do all, but I'm actually going to open up a set of values, and I'm going to do V10, V11, V12. I think that's how you do it, but we will see. And let's just do a quick commit check on that. Yep, seems to like the configuration. And now I can go into the top edit protocols. Now if I hit question mark, you can actually see right at the bottom is VSTP, VLAN Spanning Tree. So let's do VSTP, of course. Now if I just do a quick set and hit the question mark again, just to show you the different options, there are, of course, globally, i.e. at the VSTP layer, different options you can do. So we can assign this for VLAN group. That's when you group together the VLANs within the edit VLAN. So if I was to group together VLANs 10, 11 and 12, I could assign a VSTP configuration for that group of VLANs. But we don't want to do that here. Or I could just disable VSTP. We of course don't want to do that. I could force it to be a particular version. So I could do set force version, hit question mark, and I could force it to be running STP. We don't want to do that, we want RSTP. So again, VSTP uses RSTP by default, but we can also do some more interesting things like block on or block BPDUs on edge ports, as well as go into the interface. And that's where I really want to start. But first, no, actually I don't want to start there. I actually want to do that within the VLAN. So if I do set VLAN, now one thing here, don't be caught out by this, is you have to state the VLAN identifier. You don't state here the VLAN name. Junos will not like this, so don't be caught out by it. You have to state the VLAN identifier, i.e. 10, 11 and 12, and not the VLAN name, i.e. V10, V11, V12 like I've done. So if I do set VLAN 10 and hit question mark once again, you can now see I can actually enter in the interface, and that's why I got a little bit confused there. I can define the interfaces within that VLAN itself, or I could do so at the global layer, i.e. at the very top within VSTP. But I actually want to do this for VLAN 10 and for VLAN 11 and for VLAN 12. So I'm going to do set interface GIGI002. So that's going to switch to, and if I hit question mark again, you can now see I can enter in the cost. So here you can actually assign the cost. So that is actually the cost from this switch perspective for the GIGI002 interface to get back to that root bridge. You can also define a mode. So here we are actually going to do this. So I don't want it to be shared because there isn't a hub here. So I'm going to do point to point. And you can also do more interesting things as well. You can say no root port. So this basically means GIGI002 will not become a root port, and even define the priority of this particular interface. If you've got two interfaces that go to the same upstream switch and have the same cost, here you can actually define the priority, and obviously lower the priority, more preferred it is in the STP world. But if I just hit enter and do a quick show, you can see that's really VLAN 10. But there was one command I actually forgot to do, And that was, if I do set to VLAN 10 and hit question mark, it's right here, the bridge priority. Now we could see for switch 1, the priority is 4096. So let's do bridge priority, and I don't have to define 4096. No, in Junos you could just say 4K, and Junos knows what you're basically talking about. So now if I do show, that's it for VLAN 10. So I've got VLAN 10 with a priority of 4096, and it's using the interface GIGI 002, and that is point to point. But we also of course want, if I just hit up a few times, the GIGI 003 interface going to switch 3. And that's it. That is then VLAN 10. And just to speed it up, I can do the same for VLAN 11, bridge priority. So that's 8K or 8192 out of the interface GIGI 002, mode point to point, hit up, GIGI 003. Now if I do a show, you can now see VLAN 11 is now configured, but with a slightly different or higher, i.e. less preferred priority. And finally, set VLAN 12, bridge priority, 12K, interface, GIGI 002, mode, point to point, and let's just do up, GIGI 003, and to show. That's it. I've now just configured, how quick and easy is that? I've now configured VLAN 10, VLAN 11, and VLAN 12 on on switch 1. And what this basically means in English is, as you could see here, there's different priorities for VLAN 10. Let me change the color. Need something a lot brighter because it's a dark CRT. So here for VLAN 10, the bridge priority is 4K. We could see that right here. The interface GIGI 002, that's going across to switch 2. Sorry, the colors are really bad, going from dark screen to a whiter background, but we're also using the GIGI 003, and we've got really the same configuration for VLAN 11, VLAN 12, but obviously with different priority values. And in English, what this basically allows switch 1 to do is to become, when this is committed and when we've done switch 2, is it allows switch 1 to become the root bridge for VLAN 10, a backup for VLAN 11, as well as a backup for VLAN 12. But first, let's just do a commit check. And it's just telling me that the interface GIGI 003 is not enabled for Ethernet switching. So I thought I'd done that, but let's go top, edit interfaces, and let's do a quick show. Oh, I didn't do the GIGI 003, so that is entirely my bad, but that's why we've done the commit check there. So let's do GIGI 003, unit 0, family Ethernet switching, interface mode, trunk, VLAN, members, open up the square brackets, and let's do V10, V11, V12, and let's do show. And now I can see that's perfectly there. So if I do the same commit check now, that should pass. And it has. So I'm just going to do commit and quit. Spell it right. Yeah, sometimes, you know, you're typing away and you're talking on these videos, you forget to do a little command, but hey, that's why we've got these Junos commands. But switch 1 is now configured. We can now go on switch 2 and push in really that same configuration with a slight difference into the priorities. So switch 2, and let's go into the command line interface, into configure mode. Again, we need to do the VLANs because there's no VLANs configured. So let's do set VLANs, VLAN 10, VLAN ID 10. Let's do the same for VLAN 11 and VLAN 12. That's the VLANs created. Now we would do the same for the interfaces. So let's just do edit interfaces, and let's do set GIGI 001, which is going to switch 1. And let's do family, Ethernet switching, interface mode, trunk, VLAN, members, open up the square bracket, V10, V11, V12. Let's do show. What that was that? My spelling was awful there. Show GIGI 001, and we need to do GIGI 003 to go to switch 3. So I'm just going to hit up and now change this. Let's do Control A, get to the beginning a little bit quicker. Let's now change this to gig 3. And there we go. I remembered to do it this time. And now let's do top edit protocols VSTP. And now I want to set the VLAN 10. Remember, it has to be the VLAN identifier, not the name. And here the bridge priority, as you can see for VLAN 10 on switch 2 is 12K. But we want to use the GIGI 001 interface to go to switch 1. And this has the mode of point to point. And I also now want to do the same for the Gigi 003 interface. So if I do a quick show, we've now got our VLAN 10 configured. Now I need to do the same for VLAN 11. Bridge priority, you can see it's 4096 or 4K, so switch 2 will be the bridge, the root bridge for VLAN 11. And this is going out the interface Gigi 001, mode point to point, and Gigi 003. And now we'll just do the same, just very quickly, VLAN 12. Bridge priority is 8K for VLAN 12 on switch 2, going out the Gigi 001, and that is again point to point, and Gigi 003. And now if I do show, that's it. A little bit quicker there, but I've configured VLAN Spanning Tree protocol on switch 2 for VLAN 10, VLAN 11, VLAN 12, but for VLAN 11, switch 2 will be that root bridge because it has the best or lowest value, priority value, compared to switch 1 and switch 3 for VLAN 11, where it has 4K. And for all of these, we're using the same interfaces, Gigi 001, Gigi 003, and they're all point to point. So let's do a quick commit check on this. Hopefully I didn't forget anything. I don't think I did. And it passed. So now I'm just going to do a commit and quit. And now we can actually move on to the validating VSTP. So let's actually now validate that VSTP is up, running, and that we have this loop-free topology for VLANs 10, 11, and 12, and verify what links are actually discarding, what links are actually blocking traffic, and have these switches become that root bridge for each one of these VLANs. Now what I've done, you can probably just see it in the background, is I've actually entered in the designated or DES acronym for designated for those root bridges. The reason why, and I've color coded it, green being for VLAN 10, purple for VLAN 12, and blue for VLAN 11 here. So it's all color coded just to make things a bit simple. But obviously if it's the root bridge, then for switch 1 for VLAN 10 it's going to have designated ports, designated port rows. For VLAN 11, switch 2 is going to have designated port rows, and for VLAN 12, switch 3 is going to have designated rows. But other than that, what are discarding, what are a root port and forwarding, honestly I don't know. That's what we're going to do. So first let's go back onto switch 1 and just hit enter a few times. Now the validation, the show commands, they're exactly the same that I have used on previous videos. So if I just do a spanning tree bridge and just keep it simple and do brief, we can see the STP parameters for VLAN 10, for VLAN 11, and if I just hit spacebar for VLAN 12. Now ideally we want for VLAN 10 the switch 1 to be the root bridge. And how can we identify that? Well, the local parameters, the bridge identifier for switch 1 has this priority value. I don't know why it's saying 4106. Oh, that's because of there's a number of VLANs on here, so yeah, it increments that's correct. But here's the priority value, and this is the system, the chassis MAC address. And what you can see above is that under root ID, it's exactly the same. It ends in 9ED0, 9ED0. So this is basically Juno saying for VLAN 10, and this being switch 1, that the local bridge identifier ends in this particular MAC address. The root bridge for this VLAN ends in this MAC address. They are the same, and thus switch 1 is the root bridge for VLAN 10. But if we scroll down and look at VLAN 11, we could see that the MAC addresses are different. So here we could see the root bridge ends in 6FD0, where our local one is switch 1's local MAC address is 9ED0, so they're not the same. So we know switch 1 isn't the root bridge for VLAN 11. And for VLAN 12, guess what? It ends in 6TD0, tongue twister. Ours ends in 9ED0. Now just to validate this, if I go into switch 2 and just run that same command, show spanning tree, bridge, brief, and I just want to look at VLAN 11, we can see that the root identifier ends in 6FD0, and switch 2's MAC address, chassis MAC address ends in 6FD0. and it's not the same. We've already validated who's the root bridge for VLAN 10. For VLAN 12, again, it ends in 62D0. God, too many letters too quickly. But we've just validated that switch 2 is the root bridge for VLAN 11. Now if I go into switch 3 and go into the command line interface, show spanning tree, bridge, brief, and I'm only interested in VLAN 12. Here it is, ends in 62D0 and 62D0 here. So we've just validated there that the switches, switch 1, 2 and 3, they are the root bridge for VLAN 10, VLAN 11 and VLAN 12 respectively. But let's come back to switch 1 and let's actually just do the show spanning tree interface. I'm going to keep it simple, interface brief. And note here, this is really great. VLAN 10, VLAN 11 and VLAN 12. And just like I thought and just like I showed on the display, the GIGI 2 and GIGI 3 interfaces, and you can see them for every VLAN. But for VLAN 10, they are forwarding, designated. That's why I've entered in the background. But we can now see the GIGI 2 and GIGI 3 interfaces for VLAN 11 and VLAN 12. So for VLAN 11, the GIGI 2 interface is the root port and the GIGI 3 interface is a designated port. But what we could see for VLAN 12 is that the GIGI 2 interface is alternate, it's discarding, it's blocking traffic. But the GIGI 3 interface is forwarding, it is a root port. So what I'm going to do is I'm going to color code these. I'm just going to put them onto the lab, the background, just to keep track. And there we go, I've just entered in those port rows into the background here, so you can actually see now designated root alternate for the GIGI 2 for those different VLANs, and here for the GIGI 003 interface. For VLAN 10 and 11, they're both designated, but for VLAN 12, it is a root port to get back to that root bridge, which is switch 3 for VLAN 12. So let's now do the same for switch 2. Let's build this picture out a little bit. So coming across onto switch 2, and let me hit space just a few times. Let's run that same command, show spanning tree interface brief, and it breaks us out into VLAN 10, 11, and VLAN 12. And for the GIGI 1 to switch 1 and GIGI 3 to switch 3, we can see the GIGI 1 to switch 1 is the root port. Makes sense because switch 1 is the root port, so it's going to have the lowest cost. But the GIGI 3 interface is alternate, it's discarding for VLAN 10. For VLAN 11, both ports are designated. We already know that, that's already on the screen. But for the VLAN 12, the GIGI 1 interface is designated and the GIGI 3 interface is a root port. So again, let's put this onto the display. And once again, I've just entered in those values. So what we can see for VLAN 11, we both know these interfaces are designated, GIGI 1, GIGI 3, because switch 2 is the root bridge for VLAN 11. But the GIGI 1 interface for VLAN 10 is a root port. And that makes sense because switch 1 is the root bridge for VLAN 10. But we can also now see down here that for VLAN 10, the GIGI 002 interface is alternate. It's discarding traffic. And then if we look at the VLAN 12 interface, and I just quickly swapped them around, I put them in the wrong place, we're all human. But for the VLAN 12, we can see that the GIGI 001 interface, it's designated, which makes sense because if you look at switch 1 over here, for VLAN 12, it's in an alternate port. So it's discarding traffic on VLAN 12 between switch 1 and switch 2. And because we know switch 3 is the root bridge for VLAN 12, this here is the root port. The GIGI 3 interface is the root port to get from switch 2 back to switch 3, the best lowest cost. And finally, let's do the same command on switch 3. So let's go over to switch 3 and just hit enter a few times, show spanning tree interface brief, and just like before, VLAN 10, VLAN 11, VLAN 12, the interfaces GIGI 001 to switch 1, GIGI 002 to switch 2, and of course for VLAN 12 they are designated and forwarding traffic because switch 3 is the root bridge for VLAN 12. But for VLAN 10 we can see the GIGI 1 is the root port because switch 1 is the root bridge for VLAN 10, and the GIGI 1 is it's a direct link back to switch 1, so it's going to be the root port, and GIGI 2 is a designated port. And then for VLAN 11, the GigE 001 is alternate, it's discarding, and the GigE 2 interface is forwarding traffic. It is a root port back to the root bridge. It's got the best or lowest cost to get back to the root bridge. So again, last time, let's put those port rows onto the display. Okay, and finally I've put those port rows onto the display. So what we can see, obviously for VLAN 12, purple, color coded, they are designated, but for VLAN 10, GigE 001 is the root port to get back to the root bridge. It's got the best cost because it is a direct connection back to switch 1. But over here for VLAN 10, GigE 002 is a designated port. And that does make sense because if you look at switch 2 for VLAN 10, it is alternate and obviously discarding traffic. And then finally, for VLAN 11, we can see the GigE 1 interface, it's alternate, it's discarding traffic for VLAN 11 on this link. But over here, it is the root port because it's got the best cost, the lowest cost to get back to the root bridge. And the root bridge for VLAN 11 is switch 2 up here. So let's make all of this mean English. First, let's look at this from VLAN 10. Where are we actually discarding traffic? Well, we can actually see that there's an alternate port here on switch 2. So for VLAN 10, we are discarding, the network is discarding traffic on this link here for VLAN 10. And now let's do exactly the same for VLAN 11. The VLAN 11 root bridge, as we know, is right here. It is switch 2. Where is then alternate port for VLAN 11? It's here. It's on the GigE 001 interface on switch 3. So traffic within VLAN 11 is being discarded on this link to prevent to give a loop-free topology. And finally, for VLAN 12, which is here, the root bridge is switch 3. Where are we discarding traffic? Well, we could see right here, the alternate port is right here on GigE 002 on switch 1. So we are blocking, discarding, getting rid of traffic for VLAN 12 on this interface here. So just in a few minutes there of mapping out on a graphical interface, obviously what ports are forwarding and what ports are discarding traffic, you can see for each VLAN there is a loop-free topology, and that is because we use that priority value to elect a root bridge for every different VLAN. So switch 1 was the root bridge for VLAN 10, switch 2 was the root bridge for VLAN 11, and finally switch 3 is the root bridge for VLAN 12. And because of that, and because each switch then has a root port cost, a cost to get back to the root bridge, that then dictates what ports are going to be forwarding traffic and what ports are going to be discarding traffic to create that loop-free topology. So that's it, everybody. That is the end of this video. That is really the end of this series into Spanning Tree. And over the last few weeks and videos, I've done quite a bit of content into Spanning Tree Protocol, Rapid Spanning Tree Protocol, Multiple Spanning Tree Protocol, and on this video, VLAN Spanning Tree Protocol. And obviously for each part, the theory, the benefits, why it was created, and of course the configuration and validation on Juniper devices into each one of these separate protocols. But in summary, I hope you enjoyed that video. I hope you found it useful. Any questions or comments, let me know down in the comments box. I love hearing from you guys. If you like this content, if you like my channel, please give me a thumbs up. It's the best way to support my channel. Other than that, thanks for watching and goodbye.